In this video, we're going to be discussing percentile. A quick definition for percentile is the data value below which a percentage of data falls. So imagine, for example, sometimes when you have children, they go to their pediatrician, you're told what percentile height, what's the percentile height they are. So for example, suppose that you're told, let me get a pen here, suppose that you're told that the height percentile that your child falls into is the 90th percentile. This is not 90%. Some nomenclature, we sometimes will use this shorthand, and this means 90th percentile. So let's take a look at what that means. It's really, where is your child's, if you listed all the heights of, the heights of all the children that were used to figure out this information. If you had them all in a list, where would your child's height be? Well, it would be sort of at the 90th percent, it would be near the tallest, right? 90% is relatively tall. So what does P sub 90, that's how we read this, meaning the 90th percentile. What does the 90th percentile means? It means that 90% of the data values fall at or below that percentile, that 90th percentile. Because if you think about, all of our data has to equal 100%. If this is the 90th percentile, then we're saying that this height here, okay, is as tall or taller than 90% of the data. What that then also means is there's what's left here. If all of this equals 100%, what's left here is 10%. So that means 10% of the data lie above the 90th percentile. And you can use that percentile to actually calculate how many scores are above or below. So if you had a sample of 400 scores, there are 360 scores at or below the 90th percentile. And you would do that by finding 90% of 400. And if you remember how to do percentages, that's saying 0.9 times 400. And if a sample consisted of 400 scores, there are 40 scores above the 90th percentile. So that means you're looking for what percent? If 90% are below, that means you're left with 10% are above. So 10% of 400. And again, you would calculate that by doing 0.1 times 400. The question that we're going to look at is how to find the kth percentile. If we have a list of data, how are we going to actually find a particular percentile within that data? What we do is we have to find its location, and so we're going to make an estimate. And the formula we use for this is I, which is standing for the index, equals K, my percentile over 100, times N, the number of data samples in my data set, plus 1. And this gives us a location estimate. Note I say estimate because it may not exactly be the index of where the data exists in our data set. So, with any formula, you really want to see each thing defined. K is my percentile, A is the index or the location of the kth percentile data point, and N is the sample size. So we calculate this estimate, and giving that estimate, we have to follow this algorithm here. An algorithm is just sort of a set of steps. It's like a recipe. So is I, which is my index here, this index here, is I an integer? And just to remind you, because these are locations, they're going to be positive. So we're looking for integers that look like this: 1, 2, or 3. Those are integers. Not integers are things like 1.25, 6.75, that sort of thing. So you look at your index that you calculated here, and you have to make a decision. Is it an integer? If it is, then that integer is the location of my kth percentile. And if it's not an integer, then we actually have to look, around above and below that index, right? And average. The algorithm we're going to follow is we're going to take the average of those numbers. So let's take a look at how we're going to use this process. In this example, there are 29 ages. So when I'm reading a question, I start pulling out my data. If there are 29, that means my sample size is 29. 29 ages for Academy Award winning Best Actors in order from smallest to largest. So I look at my data and I say, okay, so the youngest person to win an Academy Award for Best Actor. So the youngest is 18 and the oldest is 77. And there's, quite a range in between there. Let's look at finding the 70th percentile. This is how we denote 70th percentile. So we're going to identify our variables. Remember, the formula we're using for the index to find the index is this formula right here. Okay, so we're trying to find our index. That means we need to know what our k is and what our n is. This step here of writing out your actual values, do that. It's very important. And so I substitute in my values here. So k is 70. So I have 70 is going to go right here. So I have 70 over 100, which is 0.70. My n is 29, so I have 29 plus 1. And if you calculate 0.70 times 30, you get the value of 21. So we're told, or not told, but we've calculated that I is equal to 21. And so now we have to look, is 21 an integer? It is, right? 21, so we're going back here, aren't we? We're going back here. This should say I is equal to 21. Is that an integer? Yes, it is. So that means that the k, remember k, our k was 70. So the 70th percentile is the data value in the 21st location. So with an index of 21, I literally have to count to the 21st location. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. This is the value that's in the 21st location. So my 70th percentile is this 64. Let's take a look at another example. In this case, we're trying to find the 83rd percentile, okay, P sub 83. So again, write down these values. K is 83, N is 29. It's also helpful to write your formula. Make sure it's right in front of your face. Don't try and just remember it. Make sure it's right there. So K over 100 is 83 over 100, which is 0.83. I plug in my 29 here, so I have 0.83 times 30, and that comes out to 24.9. So this again is my index, right? And not only is it my index, it's really my index sort of estimate. And so is it an integer? The answer in this case is no. So my percentile is going to be the average of the data points. Remember, average of two things would be add them up, divide by 2, in the location above and below the 83rd percentile that we're looking for. So because it's not an integer, we look at data points in positions 24 and 25, right? This is 24.9. So if you think about, here's my data. If I have, let's see, well, we know this is the 21st, 22nd, 23rd, 24th. So this is my 24th data value. This is my 25th data value, and I calculate the average of that. So 71 plus 72 divided by 2, and I get 71.5. Right, so think about, I don't have a lot of room to write here, but let me just change my pen color so it might help emphasize what I'm trying to communicate. Is it this right here, right? This is the 24th position, and this right here is the 25th position. So when we calculated out our 24.9, right, our 24.9 is in between here, right? And that's why we average those two data values.